Good afternoon. We're delighted to welcome you for our monthly webinar series, co-sponsored by the MGH Center for the Environment and Health, Brigham and Women's Hospital, and the MGH Institute of Health Professions Center for Climate Change, Climate Justice, and Health. Today, the topic is housing, climate change, and environmental justice. And I'll briefly mention I'm Dr. Patrice Nicholas. I'm professor in the School of Nursing at the MGH Institute and also director of the Center for Climate Change, Climate Justice, and Health. I'm joined by Dr. Sue Ellen Brakey, the Associate Director of our Center for Climate Change at the MGH Institute and also Associate Director of the Center, Dr. Barbara Belanger from the MGH Department of Nursing. And I bring greetings from Dr. Winnie Armand, Director of Education for the MGH Center for the Environment and Health, and also Dr. Greg Fury, who will be joining us. He is Medical Director for Climate and Sustainability at Brigham and Women's Hospital. Next slide, please. Today's speaker, and we're delighted to have him join us, is Dr. Jonathan Levy. Dr. Levy is professor and chair of the Department of Environmental Health at the Boston University School of Public Health. His research centers on urban environmental exposures and health risk modeling with an emphasis on spatiotemporal exposure patterns and related environmental justice issues. Dr. Levy will share with us his expertise on housing, climate change, and environmental justice. Dr. Levy?
All right, thank you. Thanks so much for having me here today. Let me just try to share my screen so we can get underway. Look visible to all? All right, I'll assume that means yes. So I'm going to present some of our work connecting some of the threads between housing and climate change and public health with an environmental justice lens. There's a lot of bits and pieces here, so I'm just going to give some snippets of a few different projects that I think hopefully hit on some interesting themes. And I'm going to try to restrict myself to about a half an hour, so there's plenty of time for discussion, and happy to amplify on anything that I presented. I want to start actually with the end and the punchline. So I think it's important just to set the framing. Again, this is multidimensional and complicated, but I just wanted to give a sense of the themes that I'm going to cover. And the first is that housing is really central from the climate story, both for mitigation, that is for reducing our carbon emissions, and for adaptation, for dealing with the climate change that is already here. On the former, housing is about 22% of US energy consumption, and so that's a big sector to try to address and try to decarbonize. But housing is also central to addressing so many of the pathways linking climate and health. Heat waves are very obvious. If you live in an urban heat island, if you do or don't have air conditioning, all of that will have a big effect on how you can personally react or protect yourself from a changing climate. Other extreme weather events certainly have analogous linkages to housing. And there's many other pathways as well, some of which I'll cover. I think the other big take home is that we need to avoid siloed thinking as well as siloed implementation of policies. And I recognize that's easier said than done. There's a lot of complex policy landscapes out there, but a lot of the time, one agency or organization might be trying to reduce our carbon footprint and not think about the implications for public health in the near term. What does this do to indoor air or outdoor air? What does it do to affordability, especially for those who can't afford their energy bills in the wintertime or in the summer? And what does it do to our indoor spaces, making them thermally comfortable? So all of these are incredibly important as we intervene in housing, and we want to avoid pushing on a lever one place and creating problems somewhere else. We also want to take advantage of win-win strategies, and I'll show some data on that. Meaning, if by addressing climate change and decarbonizing, we can also have ancillary public health benefits, then that can motivate action in the near term and perhaps motivate more aggressive action. And the final theme really on that environmental justice lens is that we really do see disproportionate burdens across multiple different dimensions: low-income households, communities of color, tend to have, as mentioned before, more exposure to heat waves because of urban heat islands, as well as lack of access to air conditioning and other cooling. Tend to have houses that have poor ventilation, greater exposure to both indoor and outdoor sources of air pollution, and a greater risk for being energy insecure and having that heat or eat phenomenon, or just the economic stresses associated with energy bills. So as we talk about housing and carbon and climate and trying to set policy, we need to have that environmental justice lens front and center. Okay, so with that, hopefully setting the scene, I want to dip into a few dimensions of this problem and some of the empirical data that we've generated over the years. And again, as mentioned, just little bits of that work I'm going to present today. So one pathway that's of considerable interest that we've spent a lot of time on, as have others, are the linkages between climate action for buildings, again, decarbonizing, and public health related to air pollution reduction that tend to lead to near-term health benefits. So this is kind of a simplified schematic that shows how you get there. You intervene in buildings, which can be electrification or energy efficiency measures or a whole host of different strategies. If you follow the bottom path, you get greenhouse gas emission reductions, which might be the primary target, and that has some economic value that can be assigned to it in a policy context. But what we've done a lot of work on is the top row. So you do that building intervention, you're reducing emissions of criteria air pollutants like fine particulate matter or nitrogen dioxide, both from the homes themselves if they are using fossil fuel for heating, but also from power plants for homes that are using electricity for heating or cooling or other resources. And then that's going to benefit air quality, and that'll benefit public health. And again, you could assign economic values to that pathway if you choose to do so. So this is one example of a project where we did that and set out to assign some numbers. I know that the font's a little small and there's a lot of detail here that I'm not going to talk about, but this is really just a more detailed version of the flow diagram I showed before. In this case study, we were looking at the hypothetical of what if every single family home in the US increased their insulation levels. But the same model applies for other strategies to reduce energy consumption or to change the distribution of energy in homes. So you insulate all the homes, you might use less natural gas or fuel oil, as well as less electricity. And we kind of track that through to see what that meant for emissions from homes, as well as from power plants. What does that do to air quality and what does that do to health? And then roll that all up into dollar values to allow for comparisons across the different groups. And so here's what the punchline was from that analysis. You can see that the chart shows emission reductions from both the power plants and from residential combustion. We have CO2 here, so you can tell the carbon story, but also NOx and SO2 to get to the air quality story. And you see at the bottom row of the table, the premature deaths averted per year due to the air quality improvements. And there's a host of other health outcomes that are benefits from this as well, related to morbidity, hospitalizations, and so forth, just showing deaths here as just to simplify the presentation. And it's important to note parenthetically that these benefits derive very quickly. So whereas you may not see the benefits from on the climate side for some time because there's just some inherent lag in the climate, you're seeing these public health benefits happen immediately in the year subsequent to the emission reductions. And so when you pull all these things together, put the dollar values on it, the economic savings just related to less energy consumption amount to about $11 billion a year. This doesn't account for the upfront cost of insulation, but just every year, once you do this, what is your economic savings from reduced energy bills? And then on the CO2 side, you're saving a little under $4 billion a year, given how the social cost of carbon is usually implemented. And on the public health side from air pollution, a little less than $3 billion a year. So interestingly, they're all kind of roughly similar magnitude. And broadly, this shows that if you're making this policy strictly based on the economics, you might not go as far or do as much as if you also included the public health benefits and the climate benefits, which certainly add appreciably to the bottom line. This was a national analysis, but we had state-by-state results that there's a lot here. Just want to kind of draw your attention to the Northeast, just in part to illustrate how this can differ across regions of the country. And obviously we're here in Massachusetts, so we can be a little bit parochial. The pie charts in each state just show the distribution of the benefits between climate and health and between power plants or EGUs, electricity generating units, and residential combustion. And you can see in the Northeast, that kind of dark blue color tends to dominate in the pie charts, which you don't really see as much a lot of other places. And that's the health residential combustion pathway. And this is because we obviously have heating needs in the Northeast that you don't have in the South and some other areas. And we also tend to use more natural gas as well as fuel oil for residential heating, whereas there's a lot more use of electricity in some of these other regions of the country. So we tend to be dominated much more by the residential combustion side of the story, both for health and climate. That's the dark blue and the light blue, as compared to other regions of the country. So now I want to pivot to a couple other topics that hopefully gave a very broad brush about outdoor air pollution and the connections to building electrification, or just in general reducing the impact from housing. But there's a lot more to the story. I think first there's the environmental justice lens. How do we think about outdoor air pollution disparities, and how would these measures help or not help? And then there's the indoor environment that needs to be taken account of when we're thinking about housing. So I'm going to touch on each of those a little bit as we go through. So first, I just want to talk a little bit about outdoor air pollution disparities in general. This is going to be only loosely tied back to the what can you do about it with housing, but just to set kind of the landscape of what we tend to see and what the implications are. So this chart is taken from a study we did a few years back to look at whether there were any environmental justice issues related to air pollution in Massachusetts and how that had changed over time. So this chart is showing fine particulate matter over an 8-year period, and the lines represent urban and rural parts of the state. Urban is the solid lines and rural is the dashed lines. And then within each, stratifying by race ethnicity to get a sense of whether there are racial ethnic disparities. And we do the urban rural split so that we can be clear whether this is just about the broad geography of where folks live or whether there's something else going on. And what you can see is that there's obviously more air pollution in urban areas, and we see disparities and differences that exist in both urban and rural settings. So within urban settings, Hispanic populations have the highest exposures consistently over time. Non-Hispanic whites have the lowest exposures. That's the blue line and the green. When we move over to nitrogen dioxide, which is a traffic-related pollutant and shows even more extreme differences between urban and rural settings, and you see, unsurprisingly, the solid lines urban are higher than the rural lines. And you see, once again, a spread across racial ethnic groups within urban settings, with Hispanics consistently having the highest exposure, non-Hispanic whites having consistently the lowest exposure. You can also see parenthetically that patterns tend to move up and down consistently across all groups based on broad meteorological patterns that have shifted the concentrations over time, as well as progressively cleaner environment as we get cleaner and cleaner technologies in place. So one thing that we looked at, though, which we were very interested in, is how housing plays into this as a potential modifier of exposures. We'll talk about it as a source in a minute, but we don't spend that much time outdoors. So the question is, as we are inside our homes, what do our exposures look like to pollution of outdoor origin that infiltrates into the home? So without getting in the weeds of how we did the modeling, we estimated both air pollution across Massachusetts and air exchange rates for homes, or infiltration rates across homes in Massachusetts based on their physical characteristics. This is just a map showing what those results look like, with a little hard to see the detail. And then pulled those things together to say, what does that actually mean? Does this heighten the disparities in exposure? Does it help to address it, or does it really have no effect? And so here's what we found in aggregate. So again, just to orient you here, looking at the plots from left to right, the first two bars are looking at outdoor PM 2.5 levels, very similar to the chart I showed a few slides ago, stratified by race, ethnicity. And low is the folks who have the lowest outdoor air pollution outside their homes, and high is the highest. And what you can see is that the low is disproportionately non-Hispanic white, and the high is disproportionately Hispanic, as well as non-Hispanic, Asian, Black, and other racial groups. And so this is consistent, again, with the charts I showed before. The next two bars are looking at air exchange rate, again, how leaky a home is, how much infiltration you're getting. And you see very analogous patterns with racial ethnic disparity. So you pull those two pieces together, you get the charts on the right-hand side where the low group are the people who have low outdoor pollution and less infiltration into their homes of that outdoor pollution. High group, that's high outdoor pollution, high infiltration in the homes. And you see very stark racial ethnic disparities there, where the low group is somewhere on the order of 4% other than non-Hispanic white, and it's about a little over 40% for the high group. So we have some stark disparities. We have not actually done the modeling to then break apart what would happen if you intervened in different source sectors. So I've pulled a very interesting chart from a recent publication from another group. This is a national scale study done by a group out of, I think, University of Washington. And what they did was look at targeting different sectors across the US, which ones would kind of give you the most bang for the buck in terms of reducing air pollution disparities. And you can see actually addressing cooking, this was, I think, largely commercial cooking, although it's a small part of the emission inventory, does the most per ton in bringing down air pollution disparities. Residential gas combustion is number 3 on the rank order list. So again, and housing, and you see residential others kind of in the middle. You know, housing is clearly a key element, and dealing with heating from housing can be an important part of the puzzle for addressing disparities. Now, pivoting on to the indoor environment, again, everything so far has been about outdoor air or how your home affects how much of that outdoor air pollution comes in. Indoor sources are a big part of the story as well when thinking about housing and exposures and potential environmental justice issues. So we published a paper, a decade or so ago, arguing that the indoor residential environment was really an important frontier of environmental justice work. Environmental justice work kind of traditionally grew up in the 80s and thereafter, looking at industrial sites and whether those industrial facilities were being disproportionately placed in communities of color. That's incredibly important, and that work needs to continue, but housing is a key part of the story. There's clearly racial disparities for a host of different reasons in what neighborhoods people could live in, what houses they can afford, and what the quality of those houses are. And so there's strong fundamental reasons why you might expect there to be, again, related to redlining and a host of other policies, very stark environmental justice issues in the housing sector. And so this figure kind of shows the litany of reasons why, or contributors to those disparities. You can have differential indoor sources. You can have different exposure to outdoor sources where pollution can infiltrate indoors, and differences in the physical structure of the homes that can modify exposure, as well as activity patterns in the homes. And so just as an illustration of this, we looked at this question in a field study where we took measurements in homes in Chelsea and East Boston in recent years. And these charts are kind of small font. I'm going to zoom in on the next slide so you can see it a bit better. But just looking at this with a broad lens, this is looking at fine particulate matter level inside of a number of different homes, and we've chopped it up here into renters and multifamily units on the left, homeowners, multifamily units in the middle, and homeowners, single family on the right. And this is showing distributions of exposure. So the far right is sort of the high exposure folks, the far left are kind of medium exposure, excuse me. And each bar, the red is the percent that comes from indoor sources or non-ambient, and the gray is that comes from outdoor sources infiltrating indoors. And what you can see kind of at a broad view is the red is almost invariably bigger than the gray. So you're getting more exposure from the indoor sources than from outdoor sources. And that gap is even greatest for the most exposed people. And so that, with the zoom in, you can see a little bit better. These are for renters in multifamily units. You could see for the highest exposure folks, the 95th percentile, 95% of their exposure is coming from indoor sources, only 5% from outdoors. But even for the folks at the median, it's still 78% coming from indoor sources. So in most of these homes, the contribution of indoor sources is actually greater than outdoor sources infiltrating in, and these are for, again, homes in Chelsea and East Boston. So given that this is a talk in January of 2023, and I'm talking about indoor pollution sources and environmental justice, I kind of have to talk about gas stoves for at least a minute or two. I don't want to spend too much time on it, but it's been so much in the news over the last week or so, it kind of has to happen. So this chart is from a somewhat older study, but which I think is still germane to the discussion. We did a study in Boston Housing Authority units a couple decades ago. Part of that study involved measurements of nitrogen dioxide inside and outside of those homes, and indoors, both in the kitchen and in the other living area. And what this showed, if you just look at the top 3 lines for a second, you know, the mean indoor NO2, the mean outdoor NO2 in these settings is about 21 parts per billion in the heating season, about 50 in the kitchen, and you can see similar things in the other rows. So broadly in the kitchen, we've got about double the concentration of NO2 as you have outdoors in developments that were pretty close to busier roads. So, you know, in these public housing developments, in part because of small unit size and inadequate ventilation, we're getting quite large contributions of the gas stoves to nitrogen dioxide averaged across days and weeks. So this is not just peak exposure during cooking time, this is averaged across days and weeks. And so we built a host of different models, and again, don't worry about the details in this chart, but this is just to show that we have this model structure that we built up to be able to simulate what do different sources contribute to indoor air pollution, what happens if you change around aspects of the sources or ventilation, and then probably most importantly for this audience, what does that actually do to the health of pediatric asthmatics who live in those homes? So we built this model to simulate basically what happens to air quality, what happens to health, and what happens if you intervene. And so this chart is showing one aspect of the results, and again, there's a lot here. I just want to talk about a couple of bars. What this is showing is the percent change in serious asthma events for a pediatric asthmatic in the home as you change around different aspects of the indoor environment. So the first bar all the way on the left says fix fans, so that has to do with repairing a broken kitchen exhaust fan so that you now have a fan that is venting to the outdoors over the stove. And so that actually reduces serious asthma events by 7% in the simulation. Replacing the gas stove, per the conversation of this past couple of weeks, also leads to about a 7-8% reduction in serious asthma events. And then actually, I want to draw your attention just to the last 4 bars on the right, which I think are really important to the broader conversation. So the very first bar, the tallest one you see there, it says reduce leakage category. This has to do with tightening the building envelope, presumably for energy efficiency purposes. And if you do that and nothing else, you actually get a 20% increase in serious asthma events. You have in this simulated household both cooking activity with a gas stove and you have a smoker in the home. You tighten the envelope, you greatly increase indoor air pollution, and as a result, you have worse outcomes. In the next bar, though, you are doing that same thing, tightening the building envelope, but you fix the fan, you know, fix the kitchen fan so you get better venting to the outdoors. And you can see that brings things down quite a bit. It helps to address the cooking contribution, though doesn't really do as much for the smoking piece. And then you can see as you go down the next 2 here, we've now gotten rid of the gas stove, or at least swapped out the fuel. And in the far right, we're getting rid of the stove and we're taking out smoking. And there you can see we flipped from making things worse to making things better. So there we've tightened up the building envelope, but by having better ventilation over the stove, by cooking with electricity rather than gas, and by getting smoking out of the home, we're able to also reduce adverse asthma outcomes for pediatric asthmatic. So just a couple more snapshots of results that I'm gonna wrap up and then happy to discuss. So this, using the same kind of modeling platform, just a different way of looking at things to again illustrate the importance of thinking about multiple interventions. So in this case, the first intervention, weatherization, which is the red lines, is again just tightening the building envelope, weatherizing, and doing nothing else. And these lines are showing 4 different types of households with average versus heavy cooking and smoking, no smoking versus smoking. And you can see the red lines pretty much go up for everybody, especially when the windows are closed, and for most folks, even when the windows are open. So if you just tighten the building envelope, again, air quality tends to get worse. But if you operate exhaust fans and you put in HVAC filtration, things get better. And in number 4, the green lines, where you've done all 3, and even in the presence of heavy smoking and heavy cooking, you're able to tighten the building envelope and still get cleaner indoor air by having better filtration and better ventilation. So pulling the pieces together for 1 second, we took our tools to look at 3 different bits and pieces here. And this chart is showing energy costs, what happens to the cost of energy as you do more insulation or weatherization, what happens to population health costs, that's the outdoor air pollution part that I mentioned at the beginning. So you get less energy consumption in the home, and that leads to less outdoor air pollution. And then the final one is the indoor air quality health costs as you tighten the building envelope in the presence of some indoor sources. Again, I think this had both cooking and smoking in the home. And the reason that we have these kind of 2 blow-up charts at the bottom is that actually you can't even see the energy costs and population health cost bars in the presence of the indoor air quality health costs, because they're just so enormous, whether on the adverse side or on the benefit side. So, you know, as previously, if you just seal things up and do nothing else, you have adverse indoor air quality, you add the ventilation and filtration, it gets better. But again, you could just see the scale of that is enormous in a home that has a pediatric asthmatic. So really showing that if you just focus on the energy or population health side and you ignore the indoor air side, you're really missing out on a very important part of the story. So this is my final set of results, something a little bit different, and I wanted to just kind of put it in here to round out the narrative, and then we can get to some conversation. So mostly we've talked about air pollution in the presence of climate, as well as, you know, both indoor and outdoor air pollution. But, you know, indoor temperatures are incredibly important to think about in the presence of climate change and complicated to deal with. And so we asked the question, as weather changes and things get warmer over the summer, this is in Massachusetts, what happens in homes? And in particular, what happens to people's energy bills as you perhaps have to spend less money in the winter and more in the summer? And how does that differ for different kinds of households? Some people have air conditioning and could afford to run it as much as needed. Some have air conditioning, but are economically stressed and can't run it all the time, and some don't have air conditioning at all or can't use it. So we wanted to understand what this looks like for different homes, and then how different policies affect things. Again, energy efficiency measures in the home, as well as policies to provide cooling subsidies. You know, as many folks know, there's programs like LIHEAP that provide subsidies for heating during the winter time. There's not as much in place for cooling during the summer. And in the past, I think that was viewed more as kind of a discretionary or luxury good, and providing heating in the winter was more fundamental to health and well-being. I think there's increasing understanding that we need to consider both hot and cold conditions, and especially in a warming climate, the health consequences of heat waves are going to become more and more dire, and subsidizing cooling may become far more important. So just as a quick summation of what we found in the modeling, by 2050, as temperatures rise, we estimated that heating demand will actually go down by 34%, while cooling demand goes up by about 33% for those who have air conditioning. So what that means for your utility bills overall obviously depends on how much electricity versus gas cost in 30 years, which we don't know, but at least given current price structures, your net bills would go down. For those with air conditioning, of course, you're able to battle against the increasing outdoor temperatures. If you don't have air conditioning, your exposures to extreme heat will go up. We estimated more than a 2 degrees Celsius increase in indoor temperatures for those who don't have air conditioning. If you put in an energy efficiency retrofit, again, in the spirit of reducing the carbon footprint of buildings, that is also reducing the energy bills for folks, and so that has some benefit. But you're actually, for those who don't have air conditioning, it increases indoor temperatures a little bit more still than the 2.1 degrees. So unless you're doing something about providing air conditioning access to more folks, by just focusing on energy efficiency, you're going to make more situations of extreme heat exposure. And if you're able to subsidize cooling and provide greater access to cooling for more homes, of course, that brings down indoor temperatures, more people are thermally comfortable, but of course that comes at a cost and of an increased energy consumption overall. So you can see how these different factors kind of move back and forth and balance off of one another for different types of households. So just final 2 slides to wrap up. I think that there's a lot of complexities in trying to address all these dimensions at once. It's kind of easy as an academic to say we can't be siloed and we need to think about different factors, but of course, it's very challenging to do in the real world, and that includes because not everyone has the same incentives. So, landlords may certainly would bear the cost of any energy efficiency measures or upgrades to appliances and things. The renters would see the indoor air quality implications of that, which is something that would be largely invisible to the landlords. What would happen with energy costs and who pays those bills, again, could vary across units. Right. We may act differently if we're worried about population health related to outdoor air versus people deciding on their individual health as a function of whether there's an asthmatic or someone with COPD in the household. And again, there are some things that are probably right for the long term and may or may not be right for the short term, and how we try to balance that. And of course, anything that has to do with your home, there's just a host of different behavioral dynamics and things that need to be taken account of. And, broadly, starting to do interventions, especially in existing homes versus policies for new homes, is incredibly complicated and will take a long time to implement. So to wrap up, I think, again, housing in my mind is central to the climate change story, and environmental justice is central to that story. There are real opportunities in the coming years to invest in housing in a way that can address climate change, but also, if it's equity informed, can address some of these exposure disparities that exist right now in homes. But we have to really be holistic and really account for, again, both not just mitigation, but adaptation strategies, and really understanding the indoor air quality implications of anything that we do related to housing and the built environment. And again, avoid situations where we are laser focused on one thing like carbon, and we inadvertently create problems like indoor air pollution for a host of different folks. So I'll stop there, and thanks for having me. I'm happy to answer any questions.
Thank you so much, Dr. Levy. That was really interesting. And, we launched our center at the IHP in 2017, and it's just now that I'm actually really learning about the impact of indoor air pollution. So it's really fascinating and something that we really have to consider. I would encourage people, I have 2 questions in the chat. I would encourage people to please, not the chat, the Q&A, please post your questions. I just wanted to start with kind of a quick question, and that is, the IHP is actually located in Charlestown. Right across the Tobin Bridge from us sits the Bunker Hill housing development, which is being redeveloped, as I'm sure you know. And as you were talking, I was wondering if, given this expertise in our own backyard, have you and your colleagues been consulted in any way to kind of help design those new development buildings?
Yeah, I haven't talked to them. Others may have, but some of my colleagues on this earlier project in the Boston Housing Authority, like Gary Adamkowitz at Harvard, has kind of continued to be engaged in some of the BHA redevelopment and kind of looking at the implications of that. I don't know what the conversations were on that development, but we actually had a great relationship with the BHA, both in this project and then in a few others for a number of years. And I think there, at least when I was engaged in it, I think there was a strong eye toward, how can we redevelop in a way that is actually best for the health of the residents. So it's not easy to do, but I know at least at that point in time, it was front and center in the conversation.
Great, that's great to hear. One person in the chat, this is a little bit more of a comment, but I'd like to hear your comment. There needs to be some guidance on the consumer end for the interplay of insulation, gas appliances, mini splits, etc. This person says, I'm an aware consumer with resources and I can't get straight answers or coordinated guidance for insulating or replacing my gas furnace. So there's a real need for accessible and reliable information for making changes. I'm wondering what your thought is on that. And I kind of was thinking the same thing as you were talking. Mm-hmm. As a homeowner, it's kind of hard to know, which direction to go.
Yeah, no, it's a really good point. And again, I think a lot of it is left on the individual to figure it out for themselves, which is not the best model. And even in the whole kerfuffle about gas stoves over the past couple of weeks, a lot of discussion about the need to have, optimized ventilation and making sure that you have a, adequately sized and working, range hood. And, a lot of folks either can't access that or don't know what it would take to do that. And, I think this is why in part we need, appliance standards, building codes, things like that. So it is not up to each individual homeowner or renter or landlord to kind of figure out for themselves what's optimal. I mean, certainly there's, there are places where it's done, again, in a siloed fashion, and Mass Save can come into homes and make some great recommendations for, how to reduce your energy consumption, but they don't always have a lens on what are the indoor air implications or what's the best way to try to reduce your overall contribution to outdoor air pollution, for example. So it's hard to get that in a very holistic way. I don't have an answer to the question, but I'm just commiserating and agreeing that it's a problem.
Well, I do hear you say we need to have some consistent standards, which would be helpful for sure.
I think so. Yeah. I mean, again, I don't want to harp on the gas stove thing, but that's an example where other gas appliances are required to be vented to the outdoors and gas stoves are not. So I think that's a tangible example where there could be a change in policy, which admittedly wouldn't necessarily help situations in existing housing with existing infrastructure, but would at least recognize that there, with some policy or code shifts that may be needed, and that could provide some real benefits.
Great, thank you. And just a quick aside, somebody said, what is the IHP? And that is the Institute of Health Professions, which we're one of the sponsors for this event. We're located in Charlestown. Another participant wanted to know, mentions that in some new housing developments, there are a lot of rugs, luxury spas for animals, which can impact asthma and specifically childhood asthma. Is there any action plan that you know of to assist families who are moving into these developments? Or maybe some guidance around, again, specifications like rug use, etc.
Yeah, I'm not aware of much, unfortunately, and that's not something I've looked at. I know others have. Certainly rugs can be reservoirs for allergens, and that's an issue. The allergen side of the story that we looked at a lot more in the past were both cockroach and dust mite allergens, both of which are problematic for asthma. I think that doesn't directly interplay with the carpet question as much, but I think broadly, trying to address the allergen landscape in the home is incredibly important for a lot of different asthmatics. I also noticed that in the question I mentioned about building housing closer to MBTA facilities, and I think these again are it's a complex issue because being close to major roadways obviously can contribute an outdoor air pollution source, which can itself exacerbate asthma. It can also increase walkability, which is a good thing, and more broadly take cars off the road. So it's hard to know how that works out on net, but it's again all these things. Right, it's I think important to think about it from the individual perspective. You as the person living in this setting, what is optimal for your health and well-being, and then what's the broader policy context that we want to have? How do we want to try to take cars off the road and encourage transit-oriented development, which I think is the goal of those policies.
Yeah, and like you mentioned, your work that you had done in Chelsea and East Boston, those are also two communities that are impacted by the air pollution generated by Logan Airport. And some of us went to an event that Mothers Out Front had a few weeks ago, a letter writing campaign to several people, including our new governor, to talk about the idling that happens at Logan Airport. So then you think about all those external pollutants and then the exacerbation of the internal pollutants in people's homes. And it can be pretty overwhelming to think about. I'm curious if you have any other data about specific areas in addition to Chelsea and East Boston that you looked at that were impacted disproportionately within Massachusetts?
Yeah, I mean, the first study that I mentioned, or one of the first ones, looked across the whole state at air pollution patterns. And so that really got at, urban-rural divide as well as patterns within urban areas. And we didn't sort of call out specific neighborhoods or cities there, so it was a state level assessment, but we had the data at pretty high spatial resolution. I think it was 1 by 1 kilometer resolution across the state. And then in some of these other studies, like the one I mentioned, it was the study we were specifically focusing in Chelsea and East Boston and Dorchester. So all the homes in the studies were in one of those areas. So I presented Chelsea, East Boston data. We have some data from Dorchester as well. And then in an entirely separate study I didn't talk about, we've been measuring air pollution around Logan Airport for a number of years now. And so that certainly has, includes Chelsea and East Boston, of course, but we have measurements in Revere, we have measurements in South Boston, I don't remember where else, but it was sort of at monitors that are around the compass or around Logan Airport to understand what the airplanes contribute as well as what the local traffic contributes.
Great, thank you. Someone asked, has there been any public policy change in Boston in response to your work?
Good question. I mean, some of the most tangible ones happened quite some time ago, through, again, this partnership with the Boston Housing Authority, where, the original goal of that study was to look at a suite of different interventions that could be done within Boston public housing and basically suggest which ones would be the best use of money. Like with limited resources, where should you spend the money to be most health protective? And we came down on the side of integrated pest management as being, if you had to do one thing, an incredibly important thing to try to get rid of cockroaches and cockroach allergens, and the BHA subsequently implemented a really nice integrated pest management program, and that went into place that, I think brought down both, cockroaches and asthma more generally, which was exciting to see. Beyond that, it's always hard to point a perfect causal arrow from any one study to any one policy decision, but we've tried to do a lot looking at pollution hotspots in and around Boston and just trying to raise awareness of the contributing sources. And so hopefully that has given a little bit more motivation for action. We've done stuff and around major bus depots and major highways, and tried to draw attention to what source contributions could be.
Great. Your work is just really, really impressive, I have to say. Another participant asked, with new federal incentives for greenifying houses, how do you foresee this affecting your results? Do you think it will help or hurt the racial disparities in pollution exposure?
That's a really good question. I think the devil is going to be in the details, right? So I think with the federal incentives, I think some of them could address both, the carbon emissions, which is really the goal, right? I mean, these federal programs are really aiming toward doing climate mitigation, reducing carbon emissions, but many of them also could lead to indoor air quality improvements. And so I think, to the extent that the investments are focused on things that are these win-win situations that get sources of combustion out of homes, that tighten up building envelopes, but concurrently address spot ventilation, then you could really see all the arrows pointing in the right direction, right? I think what we want to avoid, and what I think in the federal incentives there was a real attempt to avoid, are some of those situations from the 70s or early 80s, where with the energy crisis, homes were really tightened up, but without thinking that much or without a good understanding of what would happen to indoor air. And then there were a lot of issues that arose, whether mold growth or otherwise. And so I think there's more wisdom out there now, and a more kind of dynamic and subtle set of interventions that could be done. So I'd be hopeful that these incentives push toward the win-win scenarios and help to address indoor air while also addressing climate. What it will do to racial disparities, that's really hard to say. I mean, I think the skeptical side of me says some of these incentives, tax incentives for swap out of appliances and so forth, are really targeting homeowners and maybe those with more resources who can invest in these types of things. And so it has the potential to exacerbate some of the disparities if those with more means can access the kind of cleaner technologies and they've got subsidies to do so. I mean, that said, I do know that, in drafting these incentives and broadly in the Biden administration, there's been a lot of emphasis on environmental justice and trying to ensure that policies do not exacerbate existing disparities. So I think hopefully there's enough nuance there that it isn't going to point in the direction of making things worse. But any time that there's something where you're trying to incentivize purchasing of a somewhat expensive technology, right? The early adopters tend to be those with means and the resources to obtain the technology.
Yeah, definitely agree. Thank you for that. I would like to open it up to my fellow panelists to see if you all have any questions for Dr. Levy.
Thank you, Sue Ellen. I'm very interested in the implications of your work globally. Bill McKibben had a terrific op-ed a couple of months ago called Heat Pumps for Freedom and the potential impact on complex geopolitical issues globally. Do you have any comments about that, Jonathan?
I mean, I haven't read that piece, so I can't comment on it specifically. And I do think, broadly, there's some of these technologies like heat pumps that I think have tremendous potential in a variety of different settings. I think, geothermal has clear implications and ability to be implemented in a variety of different settings. And, I think, it sometimes seems pie in the sky, but weaning off of, gas, or at least reducing our dependence on gas and oil, clearly has geopolitical ramifications, right? Think about all of the recent entanglements, up to and including the Russia-Ukraine war, where, access to fuel becomes an aspect of the conflict, either the motivation behind it or influences how people are actually conducting themselves in the war to try to, restrict access to fuel. And so the ability to get out of that dynamic and to be able to have, technologies that work and are robust to those kind of conflicts. I mean, would clearly have really broad ramifications. This is way outside of my expertise. I'm not a political scientist, but it does seem like there's a ton of potential there to, extricate from some really challenging situations.
Mhm. And just a quick follow-up. It's so interesting that the Lancet Countdown reports each year have sort of a sub-theme that's so important for us to consider in a climate changing world. A few years ago, it was every child born today will be impacted by climate change related health consequences. And then 2021 was focused on Code Red for humanity. And then this year is health at the mercy of fossil fuels in fall of 2022. So your work is really important for us to think about. And again, as Suella noted, and also some of those in the Q&A, this is information that's really complex for people to digest and be able to bring into their everyday lives. So thank you for your wisdom on this issue and your research.
Sure, and I do think, I mean, generically, there's certainly some people who are motivated to act strictly on climate and to reduce their carbon footprint, thinking not about governments or organizations, but just individuals making decisions about their day-to-day actions. But a lot more people are really motivated by, their household budget, how they get people back and forth to work and school each day, what their home is like. And so it's tough to get people to have, on an individual basis, that very long-term and global lens. And that's where, again, this is kind of my bias and framing is, if it comes down to like what's actually good for the health of your family or good for the economics of your family, and then lining those things up with things that are also good for the climate, that in my mind is a big way to try to drive action. Again, it's not asking people to sacrifice their family's health or self-worth for the benefit of the global climate. It's saying, let's direct everything in the same direction. And, if you try to push on these things that are good for your home, we'll provide the incentives and structure so it's also good for the climate. And I think that, to me, will tend to turn the tide more quickly than sort of calls for broad-based global action.
And I know Greg has a follow-up question. I just wanted to make one comment that I've been thinking a lot about what you just said in terms of, what's happening right now in California, and looking on the news and seeing these flooded farm fields that have just been planted, and hearing about the economic impact that's most likely going to have on us because those crops will fail because of these crazy storms. And so really trying to get that communication out to people around, and I know this is a little bit off base from, it's about the household economy, essentially about really trying to get people to understand these are implications from climate change that we really need to all individually and collectively understand and act on.
Yeah, no, I agree. And I think channeling Gina McCarthy for a second, which I'm loath to try to do because she does it better than I would. But I mean, she would say, if we're talking about like polar bears 50 years from now, nobody is going to do anything. And so if we're talking about the health of our children and our families' well-being today, then people will act. And so I think if people appreciate, which more and more do, but many don't, that like climate change is here, it's now, it affects your health right now, today, your economic health right now, today. And so we want to take action to make your life better right now, not the polar bear 50 years from now. That I think is what can motivate change, whether it's effects on crops or farmland, or the implication of wildfires, or heat during the summer, whatever it may be. That this is happening now, it affects your health and well-being, and that's the reason to try to motivate action.
Yeah, agree. Greg, I know you've been waiting patiently.
No problem, everyone. I just wanted to follow up on this kind of these questions about the IRA and then this other kind of just discussion of the investments necessary to both kind of align our climate and health objectives. And I'm curious if you can envision a way or provide some examples of diverse stakeholders coming together to essentially kind of find a mechanism to invest the upfront capital necessary to achieve these long-term objectives. And I think particularly as it relates to indoor air pollution, climate change, heat vulnerability, it seems like health systems, insurers, utilities, essentially the building sector, many people have kind of aligned incentives here. And I'm just wondering whether there's any way in which we can kind of craft a mechanism to kind of pull those groups together to essentially make the upfront investments that are necessary to achieve some of these longer term goals.
Yeah, it's a really good question. I wish I had the perfect answer to it. I mean, I do think, cities and states that have climate action plans in place, and Boston being one, but there are many others. There's at least a roadmap and a blueprint there, and a goal, and a goal that is going to require action and investment. And so I think it's in those kind of settings, and I think that's really describing the majority of places in reality at this point, right? It's not a question of if investments will happen, it's a question of when and how. And so I think in places where it's already happening, there's a plan in place and it's getting implemented, then I think there's the perfect opportunity to bring in a host of stakeholders to really say, okay, if we're doing this, we have the goal to get to whatever 80% reduction by 2050 or net zero by 2050, wherever the goal is. But that's not our only goal for our communities, right? We want to protect people's health and well-being. And so how can we achieve this goal in a way that is best for people's health and well-being and prosperity? And then and many people are doing this, of course, this isn't a new insight, but I think then you get people at the table recognizing that the investments are happening again, and we want to be smart about how we do it. And we don't just want to kind of shuffle things around, check the box that we've dealt with climate, but not dealt with profound issues related to housing, transportation, the built environment, and trying to improve all of those in our communities. So I think there's a chance to bring in, like you said, a host of different stakeholders from different sectors to say, here's what I think would really be beneficial to health in the near term, and try to build up that narrative and build up with some small case examples, a demonstration that you can do this, that it works, and then have a positive cascade from there.
I think we have time for one more question. One more question in the Q&A. And I guess I'd like to hear what your perspective is on this question, which is, what do you see as the role of health professionals? And you kind of just talked a little bit about that, but in helping to push for policies that address both health and climate issues and housing. So if you had any words of wisdom for us as health professionals, what would it be?
Boy, it's a great question. I mean, I'm going to steal again in this case from my colleague Megan Sandel at Boston Medical Center, who's been really consistent talking about the need for health professionals to consider, like, housing as a prescription, just like anything else. And, healthy housing is incredibly important to health and well-being. And, she and others have been banging on this drum for a long time, not with a climate lens. I think we can broaden this out and sort of say, in the presence of a warming climate and given these host of different factors, you need to really think about what are the conditions in which people are living, what are potential indoor air pollution issues, do they have a safe place to go on a hot day, all these different dimensions that connect with the changing climate and also just the broader housing environment, and thinking about that as a fundamental driver of health for the patients that you see. And I think that would be, again, a really valuable thing if that started happening, to a greater extent.
Great, thank you so much. We're coming up on 1 o'clock. Clint, I don't know if you want to show people the slide, give us some information about our webinar, which for next month. So first of all, before I go into this, I just want to say thank you again, Dr. Levy. This has been informative, enlightening. Your work is just so important and critical, and we thank you so much for coming. Our next webinar will be next month, February 15th, at 12 o'clock. And the speaker will be Cecilia Sorensen, who's the director of the Global Consortium on Climate and Health Education at Columbia. She has done a lot of work trying to educate health professionals across professions to increase their awareness about climate change and health, which I think is really the necessary first step to pushing for policies in general around climate change and health, and how they impact our social determinants of health as well. And we also want to call your attention to our symposium, our annual symposium, which we'll be having on April 1st. Keynote speakers will be Carlos Ferron and Barbara Sattler, and we'll be looking at how can we influence environmental sustainability and health at the individual healthcare level and community levels, and looking at advocacy as well. So we hope you'll consider joining us for that. And I just want to thank everyone again for attending. And again, thank you so much to you, Dr. Levy.
Thanks for having me. I appreciate it.
Have a wonderful day, everybody.